Okay, everyone, we're going to get started in just a moment here. Okay, well, want to welcome all of you here this morning to part 3 of our training, which will be focused on building secure APIs and evolution. This morning we're going to be talking about not only this topic, but also a new beta of evolution that is available. And this new beta is going to be available to everyone attending today. And actually, we're going to start this morning by showing you, or whatever time zone you happen to be in, we're going to start by showing you this new evolution beta. So this is actually our largest improvement to the evolution betas that we've done so far from a feature standpoint. And what we've done is we've taken this API testing interface that was exposed, that we had built in through Apache before, and we've made this interface available directly inside of Evolution. So now you can actually run your test application and get to this interface without needing Apache at all anymore. So that's one of the big features, is that testing is now built directly into Evolution. But in addition to that, this testing interface has been beefed up in a lot of ways. And this is going to be very beneficial to you as you go through and use the application. What it does is it actually goes in and will expose all of the methods that you have published, and will give you a drop-down list of all of the methods that are available. And it gives you prototypes of the parameters for each method. So for instance, if this is for our Evolution test site, if I come in here and put in the username and password here and send that, you'll see that I get a result from the server. And let's say I wanted to go and find a customer. So I'm going to just copy that session ID, which we're going to be talking about more later. And I'll come into my list here, and I will go find customer, and we'll fill in our session ID, and we'll do a customer number. Like this. You can find direction of 2, and there we go. We found our customer. So all of the parameters that you need are brought in for each individual call. This ends up being very powerful when you have calls like add, edit, order that have a large number of parameters to them, rather than you having to, even just to test the interface, to build this all out yourself. We're building it out for you to make testing it very simple. So we think this will help you from the standpoint of getting these test cases built very quickly, and just be able to try out what you're working on right away. So anyways, there's more to what we've done than that. Some of that we'll talk about a little bit later, but we just wanted to show you that to kind of whet your appetite as we go through some of this other information today. So the real topic we wanted to talk about today really centers around evolution security. And when we talk about evolution security, of course, we're talking about API security. And there are really 4 areas of security, or 4 pillars that we're going to discuss in detail. These are encryption, isolation, which basically is the idea of making sure that an API call stays within the context of what that user or that API call should be doing. Authentication, so who are you? And then separately, authorization, what you can do. So the first topic we're going to talk about is encryption. And really, encryption is one of these areas that we see a lot of mistakes made on on a regular basis. And one of the things that we see done very often is related to users attempting to encrypt data themselves. And this is always a bad idea. In general, encrypting stuff is a little bit more difficult than it looks like. So what happens a lot of times is that encryption ends up being abstracted away into a simple encrypt and decrypt function. And you end up with a situation where you have this encrypt function that you feel that you can use to basically protect data without any thought as to how exactly that encryption is protecting that data. And what ends up happening is that encryption actually has a lot more pieces to it. So for any given protocol, there are various items that can affect how the encryption works. There's things such as the initialization vector, the nonce, the mode. All of these things affect how that encryption is going to work and whether or not that encryption is actually providing any protection for you. The other item to remember is that encrypting data doesn't always protect it. For example, you have to consider where the key for your encryption is stored. Is the data that you're trying to encrypt short and predictable in some way so that encryption may be not as effective due to various statistical methods that could be used to break it? So, and then of course the other thing that we want to mention here is that encrypting of passwords is rarely a good idea. In general, we advise hashing them. Now, in relation to that, this is an area we've actually gone over before. The issue of how to store passwords in your database. And really the key to remember is that the password is the data that people are trying to get to. So even if you're not protecting critical information, credit cards, financial data, things like that, a lot of times when there are break-ins to sites where people are trying to retrieve information from a site, they're not trying to retrieve the information related to an account. They're trying to retrieve emails and passwords. So those can be used on other accounts that maybe do contain financial information because, of course, users regularly use the same passwords on multiple sites. So even if you have a site that's as simple as just a forum, for instance, or something like that, something that maybe doesn't contain much personal data that way, it can still be very critical for you to deal with that password data just as carefully as a financial institution would deal with that data because the password is the information they're looking at getting at. Anyways, we've gone over this in quite a bit of detail before in our campfire number 10. If you go to mertech.com/campfires, you can get to a list of all of our campfires, and I think right now the first item on page 2 of that list is the one on security and web applications, where we go over passwords in quite a bit more detail. But in relation to encryption, like I mentioned, it can get very complex very quickly. And this is an example that I like to use to show just how variable encryption can be. So in this case, we have an original image, and let's say that we're trying to encrypt that image. Now, both of these next two panes here are both using the same type of encryption. In this case, I think the example that I pulled this from was AES encryption. But they're using the encryption in two different modes. And as you can see in ECB mode, which stands for Electronic Code Book, this is basically where we're encrypting independent blocks of data. You can see that there's a huge leak of information, even though we've encrypted our image in this case. The leak of information is occurring because in this case, when we encrypt using this ECB mode, effectively what we're doing is encrypting each block individually, but since the data is image data in this case, it's very leaky from the standpoint of actually protecting all of that data individually. The third pane here, which is using either a CDC or CTR mode, as you can see, it appears that we have random data that we're getting here. And that's what you, in general, want to see from a proper encryption protocol. You want to see nothing that tells you anything about what is even encrypted in this case. So the difference between the two of these, one of them is using ECB and the other one, let's say it's using CBC, which stands for cipher block chaining. Basically, in the case of the CBC, we're using the prior block's data to encrypt the next block of data. It serves as what's called an initialization vector, which is one of the other things we mentioned earlier, for how the encryption works. And this sort of stuff gets really complex very quickly. For instance, we've seen recent case of this in relation to the web application framework, where they had some security issues related to the encryption protocols that were being used. In that case, we were dealing with a situation where they were using a stream cipher, and stream ciphers a lot of times have a side effect related to what's called a key stream retrieval in them. And key stream retrieval means that I don't even need to know what the encryption key is to not only be able to retrieve data from the encrypted stream, but also to encrypt new streams of data with it. So these things need to be thought through very well when you're using encryption. Fortunately, when you're doing this sort of thing, a lot of the servers handle these issues for you. And of course, if you're dealing with Apache or IIS, they have secure socket layer built in, which handles a lot of the encryption for you. What we were talking about before is if you were trying to encrypt something yourself. When we talk about encrypting our connection, in general, the encryption is very similar. But of course, we know that these vendors have also had their issues. So a few months back with OpenSSL, which is what Apache uses, we had the widely publicized Heartbleed exploit. And but you know, IIS has also had its fair share of exploits related to encryption. In just in the last 3 weeks, we've had the Windshock exploit, or the S-channel exploit, that's come out for all current versions of Windows. Actually, if you were using IIS on XP, for instance, this hasn't been patched. Microsoft didn't release a patch for the Windshock exploit, which basically allows for information to be retrieved through an SSL connection due to an exploit in the SSL implementation in Windows. So even in these cases, the point to get at here is that encryption is not your only means by which you need to deal with securing your website. SSL is a good thing. Vendors have in general done a good job of implementing it. But doing any sort of encryption yourself is problematic, and relying solely on encryption is a bad idea. So what tactic can we add on to encryption to improve the security of your API? Isolation is the primary method that we use to add protection into your application. Isolation can be broken down into 3 areas that we're going to consider: multi-tenancy, session management, and this probability theory one we're going to talk about at the end a little bit. So basically, multi-tenancy is primarily a concern for SaaS applications. This is where we get into some of the cloud issues. And having multiple tenants accessing one database schema has its own security concerns, and that's how we're going to be talking about multi-tenancy. Session management we'll go over in just a second here, and we're going to look at some code in relation to that. And like I mentioned, the probability theory we're going to talk about a little bit later. So session management actually comes in many forms. Now, sessions aren't inherently related to logins, but often they go together. A session can be handed out without a login. For instance, if you have something like an anonymous shop cart, you'll see this on various websites where maybe they allow you to add items to a shopping cart without having an account of any sort, and you may be able to go all the way through a purchase anonymously, where you just put in your billing information at the very end of the transaction. these are all using sessions as well. There's nothing that makes these any different. So sessions basically give us a way of authenticating a user or tracking a user in some way. And the way we're going to be talking about sessions is a very specific means that's standard to a lot of business applications, which is related to a standard username and password login type session. So in that case, a user is going to authenticate and to the server. The server is going to return a session key or a token, and that token is what authorizes calls to an API. Basically, what occurs is on each API call, this session token is going to get passed in and verified for the purpose of verifying that we have a valid session that hasn't expired, for instance, or and has rights to call this specific API call as well. So we're going to look at how this sort of thing could be implemented in Evolution. So we're going to switch over here. And this is the source code for our Evolution demo that's at evolution.mertechdata.com. And basically, the first call we're going to look at is this user login call. And as you can see here, the user login call, we receive a person. Now, in this case, on this server, we don't have any encryption. We don't even have hashing of passwords. It's just a demo server to play around with. So this is a very simple setup that just shows the basic principles involved here. But essentially, as you can see here, we're passing in this case, a structure that contains a username and password that we call a person in this case. And essentially, what happens here is we come in and do we basically create a record in our session table that, as you can see, has a GUI associated with it, or we generate a DB GUI. And we record the session as being active. We store the ID of the user and the username. And basically, we return that session key, the session ID, to the client in this case. And then when we're going through on our functions, go in here to find order, for instance, every function takes as its first parameter, in this case, a session ID. This is how we've chosen to implement it in this example. And the very first thing that occurs on each function call is that we go in and call this validate session, passing that session ID. And basically, we have very simple logic here. If the session is invalid, we return invalid session and basically return out of the function without having done any work. If we go look at how we've implemented our validate session, we're actually doing some time validation in this case, where we've set some amount of time as a valid timeout here. I'm not exactly sure. It looks like we have our timeout set to 120 minutes in this case. But essentially, we go in, we find our session based on the session ID. If the session ID is no longer active, if someone goes in and manually deactivates it, we fail directly out of the validate session. You're going to get an invalid session. Additionally, we do our validate right in here for the timeout. If we don't get into this block of code, you can see we fall directly out as well. And then inside of here, if everything looks to be in good shape, we go in and we update our session time, basically, so that we can track excuse me, when activity is occurring for each session that is currently logged into the system. So it's a very simple system. If we look at the table related to this, to our session management, you can see our table structure is very simple. We're using a UUID-based column for this, which of course is something that Flex to SQL supports. We'll talk about that in a little bit later. And we also are storing our users with a UUID-based column. And then essentially we store some additional data to help us track what's occurring with sessions here. The session structure is very, very simple. So it makes it real easy to see what's occurring with various sessions. It's as simple as a single SQL call to see how many active sessions are there. So it ends up being a extremely simple interface to use, not only for the API developer, but also from the standpoint of implementing a front end against something like this. We have a very simple interface in place. So let's go back here. One of the things that we're going to talk about next in relation to sessions, though, that we do have to be careful of is session contamination. So once you have this concept of a session down, you have to think about what type of data ends up being persistent across connections. And persistent data is, in the case of an API, actually your enemy. It's not something you want to see. The reason this is the case is that when you have persistent data in your application, especially things like properties on the server, they can leak from session to session if you're not careful. And they can leak in very subtle ways. And so basically we advise here that in general you don't use properties that are related to a session in any way in your application. Don't use global variables, which effectively do the same thing. And essentially what we're trying to get to is the point where every function API call that you have defined is a new state machine. Essentially you have to view it as its own little independent call that should not be affected by any outside sources other than what is coming into your API call. And so we're going to, there's a couple other things to mention here as well, but we'll come back to those. So let's take a look at an example real quick of how session contamination can occur. So this is just a simple example built using Evolution here of a publish function that is using properties in this case. And if we go through here, we have our do something critical. We go in, we're doing a verification, it looks like here, of a hash to make sure that we're authorized to do a call. And you can see in this case, the reason we're using properties, the reason they're being used here is because this function needs to call other functions, and we didn't want to pass all these various properties, so we all these various parameters for whether or not this is an authorized call or an unauthorized call, and whether or not they're an admin, as you can see, those sorts of things. So we set them up as properties, and then those properties are accessed in this function called do something else that's called inside of here. So as you can see here, we go out, we do our check on this table here, we check that a record is found that our hash is matched. If that's the case, then we set it authorized to true. If they're an admin, we set it to true. If we don't find it, we clear out those properties, and then we call our do something else. So maybe in this case, you're allowed to call this function even without being authorized, and it just operates in a different manner. So do you see the problem here, though? Can you spot what I've done wrong in this case? You can see I'm attempting to do it, right? I'm resetting the properties here, right? Can you see it? What I'm doing wrong here is right at this point where I'm setting PB authorized to true. So let's run through this function and have someone that is authorized and also someone, actually, that arrow got put in the wrong place. It's supposed to be on the next line. Must have shifted my function around. So set PB admin to true is the line we're worried about in this case. So let's run through the function and see what happens here if someone comes in that happens to be an admin. So we're going to come into our function here. We're going to find the user that, let's say, their hash matches. We get into here, we set authorized to true, and the admin state on this user is true, so we set admin to true. And then, of course, it's going to jump down to this line where we say do something else. It's going to come into here. If it's authorized, it's going to do the authorized bit. If it's an admin, it's going to go off and do the admin bit. Everything's fine and dandy. Now this function gets called again, and this function is called again by an authorized user who is not an admin. So we come in, we do our same find, hash matches, we set authorized to true, they're not an admin, so we don't set that to true. But wait, they're found, it's already set to true when we exited this function call. We've given this user admin rights because the prior user had admin rights. Do you see that? This sort of very subtle thing here, just because in general what happened is before the function ended, I forgot to reset all of the properties. Just resetting them in this case wasn't enough. It didn't deal with all of the ways that I would need those properties reset back to what they should have been. This is what happens in session contamination all of the time. We just see this non-stop for session contamination type bugs. They're very hard to track down, and they really are very subtle is the reason why. So how would you go about fixing something like this? Well, here's one possible fix for this that avoids using any properties whatsoever. And really, the fix for this is related to basically using ephemeral storage or local variables to pass data around rather than using properties or globals. The way I've done that in this case is I've defined wherever I need to have something that's passed around, I've defined a structure called tparams that contains all the parameters that I may need to pass around in any given case. This structure could grow to be quite large in some cases even. And there are other ways of implementing this. This is one possible way. But what we do here is we have our params variable that's created in our function, and rather than setting properties, we basically set the value of elements of this structure based on what we would have set as properties before. So params.authorized and params.admin. And you can see here in this case, just for clarity, I am moving false to them. It doesn't really even matter in this case, but let's see what happens here when we get into or do something else. Well, I'm passing the params by ref. The reason I do that is so that if other functions need to modify the value of these parameters for this run of this API call, you're able to do that very easily. So I pass it by ref to all of the other functions where I need it so that I don't have a ton of parameters building up, just a single parameter. And then, of course, I use them just as I would any other variable of this type in my code. But the nice part about passing everything this way is that, of course, as soon as this function returns its value and the function ends, as soon as that scope disappears, all of that data is gone. There's no way we can leak it into another call of the function. So it ends up being a very effective way of avoiding session contamination. Now, the other concerns for session contamination really relate to having detailed logging in your sessions so that if you do have something occur, you can basically track what's going on. So certainly we advise logging in them. And the one other thing to think about in relation to sessions is that you want to be careful about storing important state on the server only. So let's say that you do have session-based data that you need to store as a session gets built up, and so maybe you have a larger session table for that or something like that with additional fields. The important thing is for this state data to only be located on the server, because remember, we can never trust the client. Not only for web applications, but for all types of API-based applications, we never trust our data from the client. So we never give them anything important that we need to track that they could change and then pass back to us that we don't know about. So store important state data on the server. The next thing that we're going to talk about is related to multitenancy. Now, this is something, you notice I've got the cloud up there. This is something really that's going to be focused on those that are providing SaaS-style applications in general. Multitenancy is basically the concept of having multiple tenants or multiple users. It could be multiple companies if you're providing a business-type SaaS environment, all running on a single instance or identical instances of an application that's being hosted. And really, there are multiple ways of implementing multi-tenancy. At the low level, we have what's called SaaS level multi-tenancy, which basically involves building out multiple copies of your application. You can have a copy running for each customer, for instance. That would be a very simple, low-level SaaS implementation. At the other end of things, we have a high-level SaaS multi-tenancy implementation that would involve having a single database schema serving multiple companies or customers, multiple tenants, all running on a single instance. And this is the situation we're going to be talking about here, where you have one database that has to serve all of these different customers, and you need this isolation of the data between these customers. What some developers immediately go towards is having basically multiple databases, one database for each customer. But this is actually, in general, not a very good idea. And one of the biggest reasons you don't want to do this is that it's very expensive in basically a stateless environment to switch databases on the fly for each possible incoming API call. So we've certainly have seen implementations like that, and there's a lot of cost to doing that switch. And so basically you're adding this slowness onto your application for every single API call to switch to that customer's database. So we do not advise doing that. What we do advise doing is basically having a layer that's sitting, basically another table that has a company ID associated with it for each individual tenant, or a tenant ID of some sort, so that basically at a very base level from a session standpoint, you know what tenant ID you're dealing with, and you're able to find that tenant's data by constraining all of your tables to that tenant ID or customer or company ID, whatever the case may be. When you do this sort of implementation, the one critical thing to do is to make sure that that ID is on every table that contains unique customer data, rather than just having it on a top level, on your top level tables, and then being dependent on just the relational structure from there. Put this ID on every single table. For one, if you ever have any sort of problems with your database, one of the benefits of having it on every table is that you know which customer's data you're looking at any given moment. It allows you to add constraints across your system very easily as well on a global basis. It makes it very easy to set up after you've verified a session in an API call, to then immediately constrain all of the tables that are going to be used in that API call to that company ID, so that you don't have any risk of pulling in data from other customers. So there are some real strong benefits to doing this. This last item here about linking the constraints from the session, not the client, is also very important. Whenever we do this, that company ID shouldn't or doesn't need to be passed down to our client through the API call. In general, they don't need to know anything about that, and we don't want anything coming back from the client that's incorrect to ever get used related to a specific company ID. So you want to make sure that that constraint is handled based on data that's stored in that session table, rather than data coming from the client. There's just too much risk otherwise of something going wrong, and of course, like we said before, you never want to trust the client. If anyone has any questions, of course, feel free to ask as well as I'm going through this. The next area that we're going to talk about related to isolation is what I call isolation via probability theory. And this is the concept of using, now some of these are terms that we don't see used in the DataFlex market very often, but it's the idea of using UUIDs as surrogate primary keys. So a surrogate primary key is just the opposite of a natural primary key, which is basically a primary key based on data that is part of the information you're recording, whereas a surrogate primary key is something that's going to sit in its place, so something we made up to serve as a primary key. One of the benefits of using UUIDs as surrogate primary keys is that there is a level of protection inherently provided when you're accessing data outside of your domain. So this requires some explanation about the risk involved in not using them. So what we're going to do is we're going to take a look at a system that doesn't use a UUID to show you what can happen when those types of IDs have to be passed back to the client. And in this case, this is one that was intentionally done in the way it was done, so there actually isn't risk associated with this one. They designed it in this fashion, but it illustrates it very well. So we're going to come over here, and we are going to go to Stack Overflow. And we're going to do a search for, let's just do a search for Python. Okay. So, okay, so you can see here that in our URL, we have this ID mentioned here. You can see this ID that's embedded in the URL. And that ID looks like standard integer in this case. What happens if we change this integer to that one, for instance? Oh, well, that changed the, apparently, that ID is related to an actual post, whether or not it's a comment or an answer. By changing that ID to one higher than it was, as you can see, I've moved on to a different question, and apparently that ID was related to this answer on that question. You see, I was able to go in very easily and fiddle with the data and access something that certainly their user interface didn't intend on me accessing in that fashion. Imagine that this is a business application, though, and you have those IDs, whether they're in the URL or whether they're passed to the client and stored, just in JSON and JavaScript or something like that. Imagine if someone goes in and changes an ID, and all of a sudden they're accessing an ID that otherwise they wouldn't have been able to touch, and maybe you're not doing a check on the server to verify that ID coming back is one that they should have been able to touch. They could very possibly delete, modify data that they shouldn't have been able to access at all. And this is one of the side effects of using integers as IDs. If you're not careful, this sort of thing can occur very easily. So one of the ways we can protect against it is by using UUIDs. And in fact, this is one of the reasons that we really focused on adding good UUID support into Flex to SQL to make this very easy for you to do in your applications going forward. So when we switch this to a UUID, if you would imagine instead over here that up in this path we have a 128-bit UUID, rather than that, in this case, rather than that 32-bit integer in that case, what changes? Well, you have to plan your application around this in many cases. You may have to do some changes to your application. But essentially, if you are able to switch your application to use UUIDs as this sort of primary, as a primary key, you could guess and you could pass that ID down to the client, and someone could guess and guess and guess and guess and guess, and never be able to access another valid piece of data in your system because of how large a UUID is, how big of a space it is able to contain. So to give you a chance of collision, let's say that you had generated 68.7 billion IDs into your system. So you've got almost 69 billion IDs, UUIDs stored in your system, and a user attempts to access this. Any single attempt is only going to have 40 quadrillionths of a percent of a chance of being able to basically find a collision from an ID they're generating to an ID that you have in your database. So when we're dealing with numbers that small, we're effectively removing any possibility that someone is going to be able to access another valid record in your system. They're not going to be able to find a collision from something that they're generating, especially at the rate that you could call an API like this over the internet. You know, your collision rate, they talk about collision rates of, before you get up to a very high collision rate, like 50% for instance, we're dealing with 1 billion UUIDs generated per second for 100 years. So very big numbers here. So the way this can be used as a protection then is basically it allows you to pass these IDs down without any risk that someone is going to be able to fiddle with that ID and find something else valid in your system. That doesn't mean that you shouldn't verify what's coming from any session to see that it is authorized to be touching those records. It's still a good idea to verify it, but sometimes that verification code could end up being wrong, or a developer forgets to implement it, and this ends up being a good fallback to that from an isolation standpoint, because certainly you don't want a situation where a user is modifying something outside of their isolation area, accessing someone else's data, for instance. So anyways, just a method that you can use that we found very beneficial. There are some gotchas to doing this sort of stuff. For instance, you have to be very careful in relation to how you set up your indexes. Your clustered index, certainly you wouldn't want it to be based on a UUID, and that's something we've talked about in detail in our campfire where we talked about this feature in Flux to SQL. So the next area that we're going to talk about is authentication. And in relation to authentication, of course, there are many ways that you can authenticate a user, or it could be that you're authenticating some other entity. The most standard way, of course, username and password. We have additionally an email authentication method. This is where rather than having a password to enter, a user is emailed a one-time key that lets them into the system. A lot of users like this because they don't have to worry about passwords, and so it can be an alternate authentication mechanism. Of course, it's dependent on their email not going to spam and getting delivered quickly. There are also, if you're dealing with applications that may be more mobile, SMS-based tokenization can be used where you're passing, again, the same sort of thing you would pass an email via SMS. And of course, there's the two-factor combination of the above where you have a username and password. If they've entered the correct password, you send off a token via email or SMS to the user that they then also enter as a two-factor authorization. And then, of course, we have social network authentication. And this is where, in general, we're using OAuth to get into your system by using the authentication of another system. Now, OAuth is intended for authorization rather than authentication, but of course, we're seeing this done all over the place where you can log into some other website using Facebook or your Twitter credentials or something to that effect. The type of authentication we're going to focus on is just the very first type, but all of these types of authentication are totally possible with Evolution. And so we're going to show, of course, we already looked at this a little bit here, but we're going to basically just go back in and take a little peek at our user login and look at it in relation to this GUI piece of it again, where we're passing in a session ID. And essentially, if I were to go in here and take a look at my data here, you'll see I've only got one username in the database right now, but you can see here my user ID is a GUI'd, and in this case our session ID is also a GUI'd, and these are all of the active sessions that we have in the system. You can see some of them have become inactive just based on time, so there's various checks that are put in place here. But essentially, one of the reasons to authenticate with a token, and that's really what we want to talk about here, is that we're doing this token-based authentication. One of the reasons to do that is because of the variability it gives you in your use or someone else's use of your API. So for instance, let's say if we go and look at other systems that are out there, one of the things that you'll commonly see is that every API call will take a username and password, where authentication, authorization are all built into every single API call. This is a very common method that's used, where every call takes a username and password. There are reasons to use an authentication system that passes back a token, though. When, for instance, let's say you had a situation where you have an API that you're serving and someone else is consuming that API, and maybe that other party consuming it is a company, and they have a username and password that they use across that entire company. But this company doesn't want their employees, let's say for instance, to have access to that username and password. That username and password is theirs, but they want them to be able to use your API on a third-party basis. Well, one of the advantages of using session IDs is that you could have, for instance, a situation where an employee goes to a portal that a company provides that does a login to your API and hands that session ID off to the client, that then is able to use that session ID to directly access your API. And that username and password is stored on that company server, and the employee is never able to see that username and password. Maybe they have their own username and password that gets them into their company's portal. This sort of thing is not possible if your APIs all require a username and password on each call. So using a tokenized authentication mechanism ends up being very beneficial, and in fact is kind of the whole point of something like OAuth to begin with. So it just makes your API more useful and easier to implement for a lot of parties. I've had to deal with a lot of APIs where they did just have this username and password, and it's really a pain to figure out how you're going to store that username and password somewhere that clients aren't going to be able to access and things like that. It's just really difficult. You have to look at various proxy mechanisms to the API call, and there's all kinds of stuff you can do, but none of it's any fun. It's very difficult. So essentially, from an authentication standpoint, whether or not you're using a username password scheme, an email scheme, a two-factor scheme, sending back a token is the way to go. But authentication is only part of the answer. Then we have authorization. In relation to this, we're going to be basically this token piece of it is very beneficial here as well, that we talked about with authentication, because essentially you can pass this token around, and that's authorizing someone that may not have been directly authenticated. So authorization is truly something different than authentication. A login could be, a session key could be handed out by an entirely different system than your actual API, for instance. But if that token that's given to you is valid, you can use it to make API calls into your application. That is an authorization system rather than an authentication system. And essentially the process that we go through, we already showed this a bit, where we come in here and on every API call, we take our token, we verify the token. If the token is valid, we let them go forward. You know, if it's not timed out, we let them go forward with the API call. It's very simple, in fact. Authorization also involves business rule implementation. Oftentimes you're going to have various things that a certain authorization token will be allowed to do and not allowed to do. Maybe you'll verify that this authorization token has admin rights, and so they're able to do things that a standard token may not be able to do. All of this is part of your business rule implementation. That's all code in your API calls for you to implement. And of course, if you're dealing with a multi-tenant environment in the cloud, then your authorization will also involve doing checks as to whether or not this token is valid for this specific tenant. So, to sum up all of this, what we want to do for any type of security on an API is we want to try and make it stupid simple to use. Okay, we want this stuff to be easily understood by developers, and we want it to be easily understood by those that are actually consuming your API, whether or not that's you or a front-end developer or someone else. And the way we do that is by making these methods not only standardized for what is being done elsewhere in the industry, but also making them simple, trying to avoid adding layers on top of layers into your application. Basically reduces the number of areas in which you may have forgotten something that ends up being exploitable out on the internet. So, you know, the principle to keep in mind here is to keep it stupid simple. The last area we're going to talk about, and we're getting short on time here, I don't want to keep you guys too long, is validation. And validation is basically can be broken down into these 6 areas here. And server-side validation is something that you always want to be doing inside of your API calls. And basically this is where a data dictionary sits on the Dataflex side of things. Is you know, the idea here is that you never want to trust the client, as we've said again and again, and I'll repeat it until I'm blue in the face. And so no matter what you're doing, you always want to have validation on the server for an API call. But there are other types of validation you may need at various times. This auto client verification is essentially what we see in something like Web Framework, where basically they're passing validation data down to the client that's implementing it. This is something that's pretty difficult to implement and has lots of issues related to the implementation, and with basically the concept of being able to match the way something works in a front-end language like JavaScript to a validation rule that you may have written in native Dataflex. And so there can be mismatches that occur there, but it is another form of validation to mention. Another side effect of it, of course, is that when you have all of these calls going to the server for validation, it can be more taxing on your server. So there are alternatives to use. Manual client validation is what we're using in this simple application here. And basically what we're doing here is we're doing some basic validation client side that basically is done on a field-by-field basis in JavaScript. So we provide, you know, a list here, and we limit what your ability to type into this list something that's you know you're not supposed to. And on phone numbers, we have some validation to verify that it's a valid phone number. That's all manual client validation. Sometimes you may be able to get away with no validation as well, where you have a very simple entry and you can rely on just the server to do the validation for you. In this case, you need to be aware of the fact that if you're just having the server do validation and you're doing none on the client, if you have a lot of fields on the screen, you can really tick your users off. If they go and enter a whole bunch of stuff, hit a submit button or whatever the case may be, and then find out that 6 of the fields don't validate, or worse yet, if you fail on just the first validation, and they go and fix that one and hit validate and find out the next field is invalid. Things like that can be very annoying from a user interface standpoint. So if you're not going to use validation on the client at all, you want to make sure that you're very careful and that you're using it only on small entries. The last 2 are the more interesting types of validation. And per field validation is basically where you have a situation where for certain fields you may have advanced business rules associated with them, things like that, where just doing manual client-side validation isn't enough. And actually you do a call off to the server to verify the value in this field is not only valid but meets various other business rules possibly that involve other tables and things like that. Per field validation basically can make use of a validate field call in your data dictionary, and this is kind of a poor man's auto client validation. You can't use it to handle formatting. You shouldn't use it to handle formatting. But for other areas, it's very beneficial. And then lastly, this per page to server validation is very beneficial if you're building a wizard style user interface, and you can basically pass a group of fields up to the server to validate all of them at once and return that all to the client at once. It can even make it so you can even use that in place of manual client-side validation as well. And essentially, these are the reason I wanted to mention these is not show you implementations of them, but just to get you thinking about the different ways that you can validate something. You know, you don't have to, a lot of times the thought is just server-side validation or just manual client validation, and there are lots of steps in between those two that you can implement here. So, you know, we want to make sure we get you thinking in that direction in relation to evolution too, because it's very possible to implement per field and per page server with evolution if that's your needs. So that's basically the areas we were going to go over today. We had a couple other areas that we wanted to talk about. We're not going to be able to get to those though, but we do have something new to announce to you here, and this is our evolution forum that's available at forums.mertechdata.com. And actually, we're going to continue the discussion there on exception handling and unusual API calls. And this, right now, these forums are set up for Evolution beta participants only. And so all of the attendees and beta users are going to receive an invite after the webinar this morning to the forums. So you'll be able, the way it works is you'll receive an email with a link you can click on. You'll automatically be logged into the forum. I'll give you just a little preview of what our forum looks like. We've already got some topics in there. We've got a new blog post on reverse proxies that I think you guys will like. And of course, you have access to the new Evolution beta version directly from the forum as well. So you'll receive an email with that link. You'll automatically be logged in at that point. Once you click that link, you'll receive a second email that lets you set up your password for the forum. But right from that very first link that you click on, you'll be able to navigate around the forums. And so we're looking forward to seeing you guys in there and giving us some feedback on the new Evolution beta. You can try it out with this new testing interface that we have in here. And effectively now, we're pretty much done. I want to open this up to questions now. If there's anything that you'd like me to go over in more detail or anything like that, please feel free to ask. If you haven't joined the beta program yet, if you'd like to be able to get access to some of this stuff, go to mertech.com/beta and fill out that form there, and we'll get back to you with an invite to the forums so that you can download the beta of Evolution. Like I said, we have this new reverse proxy article that talks about the Apache reverse proxy implementation and others as well in quite a bit of details. So I think a lot of you will like to take a look at that and kind of get an overview of what you can do with a proxy server, with a reverse proxy server in this case. And if we don't have any questions then, I thank you all for joining us this morning. And we don't have a date scheduled for our next training or webinar yet, but certainly you'll be getting an email shortly with that information to let you know what our topic will be for our next training session or our next webinar that we're doing. And hopefully you guys will join